So welcome to this latest video 162 Maths, and in this video we'll be going over some past exam questions related to scatter diagrams. Now I'll also include a copy of the questions that we go through in this video in the description below for you either to have an attempt at before watching this video or while watching this video as we go through the answers. And I'll also go through what it is you actually need to revise for this topic. Now before we get started working through some past exam questions related to scatter diagrams, let's just have a quick overview about what it is you actually need to revise regarding this topic. Now here what you need to know is, one, the basics is know how to plot a scatter diagram. So again, you're plotting them just as you are with coordinates. Do not go crazy with the points, just try and make them look like you've plotted them but nothing too crazy in terms of like big X's or big chunky shaded circles. So just make sure that you have plotted this neatly, just because it makes it easier for you to plot and read the information from it. Now the next thing you then need to be able to do is be able to spot outliers. Now an outlier is a point that doesn't quite fit in with the trend of all the other points. So an outlier would look like on this particular data something that looks out there where you can see all the blue points are along a certain line, but this red point is a bit of a rogue. The next thing you then need to be able to do is be able to draw a line of best fit. Now again, remember that your line of best fit doesn't always have to start from 0. It can cross the axes where possible, but again there are certain criteria where a line of best fit has to start from 0 when it has to cross the axes. So again, just make sure that your line of best fit goes through all the points that you have gone through, but also within that data range. The next thing you then need to know is to recognize correlation and its strength. So again, positive, negative correlation, know when it's weak and when it's strong. And the last thing you then need to be able to do is, once you recognize that there are correlation, is to recognize relationship. Now in GCSE questions there is a massive difference between how you answer a question that asks you to state the correlation to to state the relationship. Now correlation is either negative, positive, or no correlation and weak and strong, whereas the relationship is basically, if there is positive correlation, it basically means as x increases, or whatever that's on the x-axis increases, so does y. And if there's negative correlation, then the relationship will be where x increases, y decreases. So now let's get started on some exam questions. Now if you're wanting a copy of these questions, all you need to do is just simply click on the link in the description below and you can download it for free. So looking at question 1, it says here are 3 scatter graphs, and we've got graph A, graph B, graph C, and question 1a asks which graph has the strongest correlation. Now for it to have the strongest correlation, regardless of whether it's positive or negative, you're looking for which graph is where all the points are as close as possible to that line of best fit. And for this one, you should have highlighted the answer of B. It then says for 1b, which line of best fit should not have been drawn, and give you a reason for your answer. Well, that's going to be A, because there is no correlation. If there is no correlation, then you should not be drawing a line of best fit, because there is no correlation. And there we go. Now you won't just get the answer just for stating A, you'd have to give your reason to get that 1 mark. Then moving on to question 2, it says A and B are scatter graphs. It says what type of correlation is shown by each graph. Well, A, you can see is kind of, if I draw a line of best fit, oh, definitely not like that. If I draw a line of best fit, freehand, I can see it's got positive correlation, but not strong. So I would say it's got weak, positive correlation. Then for B, there is absolutely no correlation at all, so I just need to write that. Then moving on to question 3, it says the scatter graph shows the length and width of some leaves, and it says for 1a, one of the leaves has a length of 34 millimeters, write down its width. Well, looking at the length, I'm looking for 34, which is here. So the one that I'm looking for is this point there. So then all I then need to do is to find out what the y ordinate is, and I make that out to be about 24. It then says for 3b, all the points except one show strong positive correlation. Circle the point on the graph that does not fit the pattern. So the one that doesn't fit the pattern, I was going to say, is probably going to be this one here. Then for question 4, it says Layla sells ice creams. The table shows the highest temperature and the sales for the 5 days, and it says she draws a scatter graph and a line of best fit, and it says write down 2 mistakes that she has made. So if I just zoom out a little bit so we can see the table and the graph in all its entirety, and like so. So then the 2 mistakes is that the first one is that she has incorrectly plotted 1780. So this point here has been plotted incorrectly when it should have been at 80, not 60. And you can say that, so it should be 1780, not 1760. Then the second comment that we need to state is the fact that the line of best fit should be steeper. Or you could say something along the lines of that it's incorrectly plotted and draw it where it should be, would be absolutely fine. Then moving on to question 5, let me just zoom in a little bit so we can see the question. It says the times Neil spent cycling and running on 10 days are shown on the scatter graph. It says the average time spent cycling per day was 175 minutes and the average time spent running per day was 160. Plot the point 175 and 160. So 175 and 160 I make out to be about there. So that's my point for point A. And then it then says draw a line of best fit through the data. Now for your line of best fit, so let me just write B here. So it needs to be, in terms of the widths, well, it definitely needs to go, so your line of best fit must go through the point in part A. Now during statistics, now you may have not been taught this, but if you've worked out the average of your X values, the average of your Y values, then your line of best fit should go through that point. Now if your teacher's not taught you that, then that's different, but again that's something that you need to highlight. Now in terms of your line of best fit, there is a boundary in where your line of best fit needs to be. So in terms of your starting point needs to be somewhere between 275 and 225, so it needs to fall within this region here. Now in terms of where your line needs to end, so it's at 275, it basically needs to go somewhere between 75 and 125, which is there. So your line needs to be going through that green line at the top and through the green line at the bottom, and preferably through that point. So if I just change the colour of the line, so I would say that seems relatively not that bad. So again, it goes through the barriers of those 2 brackets there and also goes through the point that I've plotted. The next thing we then need to do for 5C, it says on another day he spends 150 minutes running. Use the line of best fit to estimate how much time he spends cycling. So we find 150 on the vertical axis, which is here. And then what I then need to do, and you need to do this on your line of best fit, is go horizontal till it hits your line of best fit and then move down. Now in terms of acceptable answers, as long as you've drawn your lines on your scatter diagram, which is really, really important, make sure you're doing those horizontal and vertical lines. But any answer that's used from your line of best fit, that's between 165 and 225, would be accepted. Then for question D, it says on another day he did no running and no cycling. What assumptions can be made about the effect of this, what this would have on the data? So for this, you could say that it may have been a rest day. He may have been injured. He may have just been busy. But basically, you wouldn't include it. So wouldn't include in the data. So something along those lines would be absolutely fine. Then moving on to question 6, it says the scatter graph shows information about the results of 10 students in 2 tests. It says the data has strong positive correlation. Describe in words the relationship between the results in the first test and the second test. Now, if it's got positive correlation, then basically what that means, it means that if you did well in test 1, you will do well in test 2. So, but in other words, as one increases, the other increases. If it showed negative correlation, as one increases, the other decreases. So it has like the opposite effect. Then moving on to question 6b. I don't know why it says answer in minutes, but we can get rid of that. Then it says for 6b, in the first test, Hannah got 38%. Estimate her result in the second exam. So what I need to do then is on the first exam, find 38, which is about there, and then project up till it hits the line of best fit. Then as soon as it does, go horizontal, and it's this number that I want, which I make out to be around about 26. Then for question 7, it says that Sarah cycles home from work each day. The scatter graph shows information about her journey times. It says Sarah leaves work at 5:12. Use the line of best fit to estimate the length of her journey time. So to draw the line of best fit, what we need to do is first of all find the boundaries. Now again, looking at the mark scheme, the boundaries were roughly around 3:15, which is about there. And the upper bound was at 5:30. So if I just draw a green line there, and then the upper boundary was looking at 5:25 between 5:50 and 6:05, which is about there. So your line of best fit needs to go somewhere straight line through those 2 green lines. So if I then just have an attempt at doing something that would be acceptable, so yeah, I'd say there, it's not look too bad, we'll go for that. So then what we then need to do is from the line of best fit, we then need to find 5:12, which is here. So then projecting upwards till we hit our line of best fit, we then scroll across, and then we just need to read off what time this is. Now I make out that to be around about probably 5:46. So if she left work at 5:12, what's the time difference? Well, it's 46, take away 12, which I make out to be 34 minutes. So again, as long as you've used your line of best fit, whatever time this is, take it away from 5:12 to work out the minutes, and you've got your answer. Moving on to 7b, it says one day she works late and does not leave work until 6 p.m. Write down 2 reasons why the scatter graph may not be useful to estimate what time she will arrive home. One of the reasons you could say it's because it's outside the data range that's been tested. And it's something that we call extrapolation. And the other thing is you could say that after 6 p.m. traffic conditions may be different. You could say maybe worse as it being rush hour, but something along those lines would be absolutely fine. Then moving on to question 8, it says that Freddie and Priya both like music. Freddie gives some songs a score out of 10. The scatter graph shows his results. And it's for question 8a, it says what fraction of the songs are given full marks. So here we can see we've got 2 songs that were given 10 out of 10, and it's 2 out of 13, so it's 2 out of 13. It then says how long is the song that was given a score of 4? Give your answer in minutes and seconds. Well, a score of 4 is this one here, and looking at the length, that's 5.4 minutes. So that's 5.4 minutes. Now converting that into time, well, that's 4/10 of a minute. And 4/10, a minute is 60 seconds, so it's 4/10 of 60. So it's 4/10 times 60. So it's 4 times 60, which is 240, divided by 10 is 24. So it's going to be 5 minutes and 24 seconds. Then moving on to question 8C, it says Freddie has the hypothesis. He says the shorter the song, the more I like it. Comment on his hypothesis. Well, looking at the scatter diagram, you can see weak negative correlation. So as there is weak negative correlation, there is some evidence to support his hypothesis. And again, the hypothesis is just an opinionated statement. Then for question 8D, it says Priya also gives some songs a score out of 10. She has a different hypothesis. She says that the longer the songs, the more I like it. Her hypothesis is strongly supported by the data she collects, plot points on the grid to show how her scatter graph may look. Now, if it's got, this sounds to me like it's going to have strong positive correlation, so strong positive correlation. And what you also want to show is that you've plotted at least, so plot at least 5 points. So we're looking for the longer the song, the more she likes it. So we're looking at, let's say, something along the lines of this, and it should be generally, and it should go through 0. So let me just draw my line of best fit. And I would say, yeah, about there. It should be okay. So again, just want to make sure you're showing extremely strong positive correlation and you've plotted at least 5 points to get that 1 mark. Then moving on to question 9, which is our last question. It says the scatter diagram shows information about advertising costs and the revenue of a company. And for part 8, it says use the line of best fit to estimate the revenue for advertising costs of £600. Now £600 is basically, and let me just get rid of that there. So £600 is, now notice how the advertising costs are in thousands. So it's going to be 0.6 thousand. So 0.6 is here. So using the line, I make out that value to be roughly around about, now that point shouldn't be 10, it should be 20. So let me just correct that. And I make that out to be around about what, 18,000, I think. Yeah, that should be all right. It then says use the line of best fit to estimate the revenue for advertising costs of 6,200. Now 6,200 is here on the horizontal axis. So then if I then draw, actually it's going up in 2, so that's going to be 1 square. So it's going to be this point here. So it's just 1 square off from 6,000. And I make that out to be roughly just above 40,000. So I would say 40,500 to 41,000. So any answer between there would be fine. Do not give a bracket, just be a bit more confident in giving one value. It then says for 9C, which of the estimates is more reliable? Basically, we just need to say the second one is, as it is within the data range. Now, in order for the line of best fit to prove useful, the values that you predict using your line of best fit needs to be bigger than the smallest data and smaller than the largest data. So as long as it falls, let's say, more than this one here and less than this point here, it's going to be fine to predict and use your line of best fit. Anything outside that range, make sure line of best fit and any results that you use from it unreliable.